Namaskar, my dear students. Today we will learn basics of mathematics. The chapter is trigonometric functions. I know in your previous school and in 10th standard you had studied basics of trigonometry. Trigonometric ratios are itself called as trigonometric functions. You know sine, cosine, tangent, cosec, sec, cot. These are the trigonometric ratios. But the basic question comes, what is trigonometry? Now trigonometry is the branch of mathematics that deals with the relation between sides of triangle and its angles. Now we have studied in school that there is a right angle triangle and we can define sine, cos, tan ratios, etc. But we do not know that trigonometric functions or ratios can exist for any angle, and that's what this time I am going to teach you basics of trigonometric functions. Please concentrate. Consider a standard unit circle. Consider a standard unit circle. What is standard unit circle? It is a circle whose center is at origin and whose radius is 1 unit. Let us try to draw it. You see x-axis, you see y-axis. I shall draw a circle. Have a look. This one is a circle. Now this is ray OA. Okay, I have taken point A on the circle. Let this ray OA rotates anti-clockwise to cover angle theta. Now the radius of the circle is 1 unit. So OA equal to OB has to be 1. It's so simple. B has a coordinate x comma y. Let us draw perpendicular from point B to the x-axis, calling it as M. So BM is perpendicular to x-axis. Now you have a triangle in which you see it's a right angle triangle. Right angle triangle. Which triangle? Triangle is OMB. OMB. You see in which this angle is theta. Angle BOM is theta. Alright, now you have BM. Don't you see that BM is the distance of point B from x-axis? So it is always called as y, because modulus of y coordinate is the distance from x-axis. OM is the distance of B from y-axis, which is called as x. Understood? And is already written OB equal to 1. If you consider basic definition of say cos ratio, cos, it is adjacent upon hypotenuse. What is that adjacent side? OM. And what's the hypotenuse? OB. So don't you see what is OM? It is x. And what's OB? It is 1. So it is x. Cos theta has become x. Now what is sin theta? Sin theta is opposite, that is BM. BM upon hypotenuse, that is OB. Have a look. What is BM? BM is y. Y upon 1 is 1. In short, my dear friends, cos theta is always given by x and sin theta is always given by y. Students, we have learned that cos theta is x and sin theta is y. This is the outcome of a standard unit circle. Had the circle been not unit 1, then this would have been x upon r, y upon r. In the later part of video, I would show you this is not always x, it is x upon r. But at this moment, r is 1. Once you get cos and sin, these trigonometric functions can generate rest of the function. You know, tan theta is sin theta upon cos theta, and therefore it is y upon x. Cot theta is a reciprocal of tan theta and therefore it is x upon y. Sec theta is 1 upon cos theta. Cos theta is x, so it is 1 upon x for sec theta. And finally, it is cosec theta, which is 1 upon sin theta. Therefore, it is 1 by y. It's so simple. So, in short, there is a strong relation between trigonometric function and coordinates of a point. I must emphasize here that, see, in your previous standard, you had studied angles up to say 0 to 90 degree. Someone asked you what is sine of 120 degree. For 10th standard pass students, very difficult for him to answer. Right now, you should understand that trigonometry does exist for all the possible angles. It's even beyond 90 degree, 180, 270 and so on. So that is why please focus. Sines of trigonometric function, sine plus or minus, that depends on in which quadrant that terminal arm lies. What was the terminal arm? OB. You started with OA rotating and settling down at some position, that was OB. OB lies in first quadrant, might be in second, third, fourth, anywhere. That will decide the trigonometry sign. Look here, this is simple x-axis and y-axis. Everybody knows this is first quadrant, this is going to be second quadrant, this is your third quadrant, and you have the fourth quadrant. Everybody knows in first quadrant x and y both are positive, in second quadrant x negative, y positive, in third quadrant both the coordinates are negative, and in fourth quadrant x positive and y negative. Now, when it comes to first quadrant where x, y both positive, obviously all the trigonometric functions are positive, and that is why the word A has come. When you come to second quadrant, you know it is going to be x negative and y positive. Y denotes what? Y denotes sine, and therefore S is written. Something which is positive, that is written obviously sine, as well as cosec theta is positive in this quadrant. When it comes to third quadrant, x and y both are negative, and therefore wherever only x only y comes, negative. But here tan theta and cot theta, y upon x, x upon y, negative, minus upon minus is plus, and therefore in third quadrant tan and cot ratios are positive. And the fourth quadrant where x is positive, y is negative, x denotes cos, and therefore C has come. So cos theta and sec theta are positive in fourth quadrant. So you should remember ASTC, ASTC. That's the order in which it is positive. You can create a simple sentence to know it forever. That is all silver tea cups. The capital letters beginning, they denote the order in which it is positive. Dear students, we had seen that sine, cos, tan and all these trigonometric functions of any angle depends on the quadrant in which that terminal arm lies. But you should mind that these all functions are periodic function. What do you mean by periodic function? That they go on repeating their values after certain interval. You know, if you start rotating, after some time you cover 360 degree. But after that also you continue rotating, it will cover 720 and so on. So, trigonometric functions are always periodic in nature. So, period of sine, cos, you must observe there, then it is cosec and sec, it is 2 pi. What is this pi? Here is a conversion. Pi radian is 180 degree. This is a SI method of measuring angle. In your school days, you used to measure angle in degrees. But now in colleges, you learn how to measure angle in radian measure. So pi radian is 180 degree, 90 degrees of course, pi by 2. This sine and cos, here is sine, cos and so on. Here something is written called domain and range. What do you mean by domain? Domain is the value that theta can accept. Theta can accept for sine or real number. Anything you can put it. Once you put any number, what answer you get is called range. So sine theta lies between -1 and 1. This bracket, close bracket indicates -1 and 1 both are included. Close bracket indicates it is included. So sin theta always lies between minus 1 and 1. So as cos theta, it also lies between minus 1 and 1. And period for these two, of course, 2pi. But when it comes to tan, if you have little knowledge, you know, tan theta for 90 degree does not exist. You must have by hearted in 10th standard that tan 90 does not exist, and therefore we don't allow tan for angles which are odd multiples of 90 degree. And this is how it is represented. R stands for real number. It can take any value minus what? Odd multiple of 90 degree. Odd multiple is found by 2n minus 1 times pi by 2, n is integer. Once you put any theta here among this, you get answer which is odd real number, that is minus infinity to plus infinity. Period. Period is given to be pi. Pi is 180. See, in the previous graph itself you had seen in first quadrant as well as third quadrant tan was positive. So first to third the migration is of pi radian. Okay, it is same story for quad. You see the period is pi, and of course quad has the domain as all real except say 0. What is sine 0? 0. What is cot of theta? Cot is cos upon sine. You will not allow the denominator to be 0 because it will give answer infinity, and therefore cot theta cannot be anything which is multiple of pi. Pi is 180. So r minus this is its domain. What answer you get is same as tan, from minus infinity to plus infinity, and hence its period is also pi. Now two things are left. One is cosec as well as sec. Cosec is 1 upon sine. So you will not allow sine to become 0 because it is in denominator for this. Therefore it is all multiple of pi. Pi is 180 degree, is not allowed. Therefore cosec theta for theta should be restricted to this, and once you do that your answer is this. How? Have a look. What is sin theta? It lies between minus 1 and 1, so its reciprocal will not lie between that, therefore it is subtracted. And the same logic is applied for sec. Tell me, cos theta lies between what? Minus 1 and 1. Cos theta is between minus 1 and 1, so its reciprocal will not lie between minus 1 and 1, and therefore see the range. It's all real number except minus 1 and 1. So this table is utmost important. The whole of the trigonometry based on this. Domain is the value theta can accept. The range is the value of this function. Period, after what minimum interval it repeats. Students, these are the basic identities on which the great building block of trigonometry and all mathematical sciences are based on. First one, cos square theta plus sin square theta is always 1, and it exists for all theta. Second, 1 plus tan square theta is sec square theta. Within the restricted domain, we can always use 1 plus tan square theta equal to sec square theta, and the last one is 1 plus cot square theta equal to cosec square theta. So those who want to solve any trigonometric problem, they ought to know these three identities. Cos square plus sin square is 1, 1 plus tan square is sec square theta, and 1 plus cot square theta is cosec square theta. I hope you have understood the basics of trigonometric function. That was just the beginning. Our new videos would definitely be more focusing on further part of this video. Thank you.